So today we're going to learn what is the math relationship behind all the calculations you did in the day one notes. Okay, so my first task for us as a class is let's find the area of these three squares. So the information is sort of given to us on the side here. We have A is 5 millimeters in length. So where we see A, this is 5. Remember, a square is 5 all the way around. So 5 here, 5 here, 5 here. So if I want to find the area of A, remember this is a way of writing it down. How do I calculate that? How do we find the area? We used to do a whole bunch of this. Area of a square. William?
12.
Nope.
Darn it.
Length times width. And Kiana, what are the numbers we use?
Okay.
25. So we're going 5 times 5. But in exponent form, that would be 5 squared, which is 25.
Yeah, that's 5, not 6. It
Yeah.
looks like a 6.
Oh, okay. Okay, and it's the units. What's the units for this area going to be?
Millimeters.
Very close. That's the unit for the side. It would be millimeters, but if it's area, we're looking for millimeters squared. Okay? Now let's do B. So it says B is 12 millimeters in length. So the B area is going to be 12 to the exponent 2. And what do you get? William?
144.
Nice. And the units, once again, millimeters squared. Then we go on to the next one. C. C area is, this length is 13, we're told. Right? So 13 squared. What do you get, Cashel? 169 millimeters squared. Okay, so we have 3 areas here. This is the hardest question I'm probably going to ask you. This whole unit. Looking at these 3 numbers, do you notice anything? Do you see a connection anywhere? So this is maybe the hardest part. Do you see something? You have 25, 144, 169. Cashel?
Looks like the second digit goes up by 2.
The second?
Left.
No.
On like the B and C.
Oh, okay.
B and C?
The 10 position.
Oh, okay.
It's a connection?
That is a connection. I'm looking, can you connect all 3 together? Can you connect A, B, and C together? All 3 of them. Do you see it? No, with the numbers. Can you connect 25, 144, and 169 together? James?
B and C, they go, there is a 25 increase.
There's a 25 increase between B and C?
Yeah.
Yeah, that's right. So B is 25 more than C. Another way of saying that is if we just added B, A and B together, you get C, right? If you added those numbers together. Right? So if we have I'm going to write that down. The area of A plus the B area, we get equals, we got to do that black, equals the C area. Does that make sense? All right? Okay. Now, what we observed here isn't just a coincidence. This always happens. So I'm going to show you a short little video here. All right. All right. So a little demonstration. I wish I had this in my classroom. Here we have 2 boxes, 2 squares off of the side of a triangle. And they're filled with water. All right. So the demonstrator is going to spin this wheel And what we just said, hey, these two should equal that. So if we go like this, they're filled with colored water. You'll notice it. I like this demo. Right? This always happens. The two smaller boxes combine to make the bigger box, the bigger square. Okay. That kind of neat? Kind of unexpected, but kind of neat. So this always happens, not with a special triangle.
I will tell you what the theorem is in a minute.
Oops.
It has something to do with how...
There we go. So this always happens with a triangle that is called a right triangle. So one of the corners has this little box in it, means it's 90 degrees. So if this is the situation, the two small squares always add up to the big square. Okay. So I'm going to write that into a slightly different format here. Like, you know how we said this area plus this area? Well, how did we find this area? We took the side and we squared it. So we'll say the side is A and we squared it. Right? That's how we got the area for A. Then we find the area B, we took the side of B and we squared it. And it equaled the area of C, which was just the side of C squared. And starting writing the word equals, I'll put that down an equal symbol. Now, if I bet you went home and said this to your parents, most of your parents would remember this. If you said, hey mom, in math, I learned a squared plus b squared equals c squared, chances are it's like, I remember that. This is one of the things that sticks in people's mind. So this is called Pythagorean theorem. It's on the wall there. It works for right angle triangles. What it does allow us to do is, if we know two sides of the triangle, then we can calculate how big the third side is. So long as we have two sides, we can figure out how big the third side is, which comes in handy in construction and lots of different aspects, right? And if you're in my grade 9 class, I'll show you some pictures of my woodworking projects that I do, and I use some of this in it. All right. Okay, so now we're going to go over here and just start talking about some vocabulary here, okay? So the longest side is called the hypotenuse. So I'm going to write down that hypotenuse. Okay? Hypotenuse. Write it down, William. All right? So we have three sides of the triangle, right? The longest side is always the easiest to identify. And I'll show you how to identify as soon as you write down the word hypotenuse. So a right angle triangle should always have a little square in the corner. That means these two lines meet at 90 degrees. The hypotenuse is always across from this. So the longest side, the hypotenuse, is always here. That's where the hypotenuse is. Okay? So that is the most important one. That's the one we can't mix up. The other two, we can mix them up. They have a generic name, right? So other two sides we call legs. Right? So you have this one, and we have this one, right? So in our formula that we did before, A and B are sort of interchangeable. It doesn't matter if you kind of mix up which one's A, which one's B. The hypotenuse side, C, is the one you have to make sure you get right. Okay? All right. So let's go into a little bit more vocabulary here. All right. So, oops. This is just officially stating the relationship. In a right angle triangle, that's with the little thingy there, sides A and side B. And side C is where we call the hypotenuse. And our formula is a squared plus b squared is equal to c squared. So you add the squares off the legs equals the square off of the hypotenuse. And we're going to start using this to figure out missing sides of the triangle. Okay? So we'll do one of those questions probably, maybe two. Then we'll use the other ones as warm-ups before we do the assignment. So does everybody got this written down? Okay, let's go to the back side. Okay. So we want to find the missing side. We have our relationship from Pythagoras. It says a squared plus b squared equals to c squared. Okay? What I want you to do with these triangles is, you're not going to understand the reason why, but next day you will. I want you to put a plus sign in here, which we're adding the squares off the two sides. Okay? So put a plus sign in the middle of your triangle because we're going to find the hypotenuse. So off of this triangle, what is side A? What number do we have? 5. A? 5, yes. So we put in a 5 here. So 5 squared. Okay? Then we go B. What is side B? 4 squared. Okay? Now we do this calculation. 5 squared is 25. 4 squared is 16. And it equals, 41. Right? This looks like the very first step of your calculations. That's why you wrote it all out, right? Now, here's the thing. Does this mean this missing side is 41? No. What's wrong, Chloe?
It should be 5 plus 4.
Oh, it's not 5 plus 4. You're on the right track. What did this give us? This 41 didn't give us side C. It gave us the square off of side C. It gave us this thing.
So you go the square root.
So then you need to do the square root to find out what C is.
6.4.
So you do the square root of 41.
6.4.
So you go C is equal to the square root of 41. And what do we have here?
6.4.
6.4. And our unit is measured in centimeters. So this way, if we have two sides, we can figure out what the third side is. All right, how many questions do I have here? Let's just do this one here and we'll stop. Okay? So it doesn't matter which one you call A and B. We can mix those ones up. Side C is the hypotenuse, the longest side. We're going to be adding the squares. So I want you to put a plus sign there. Because we're going to be adding the squares. So you go first square plus second square equals third square. Right? First square plus second square equals third square.
So A squared plus B.
A squared plus B squared equals C squared. That's what we're doing here. Then we grab our calculator. What is the first square? 12.4 squared. We grab our calculator. Go 12.4 to the exponent 2 is 153.76. We have 16.4 to the exponent 2. We get 268.96. And what does it equal? We add those two numbers together. I'll leave that to you guys. What do we get when we add those two numbers together?
A number?
What number?
A number.
20.
A number.
No.
A number in
Read.
the 400s.
423.4.
See, I was right. A number in the 400s.
All right. Is that what everybody got?
Sort of.
Sort of. What did you get?
20.
420?
Oh, wrong question. No.
Let's see. I think I just see differing faces here.
423.
Let's go 268.96 plus 153.76. So it's really easy with this unit to make mistakes when you're punching numbers in the calculator. So you should have 422.72. Right? Really easy to be careful to make mistakes here. 0.72. Oh, why did you stop working? $422.72. Is that how big C is? No. What do we got to do, Chloe? Square root. Because that gives us the square off of C. So to find C, we need to do the square root.
20.5 or 20.6 if you round it.
20.6? Okay, so C is 20.6.
If you round it.
And what should the units be?
20.6 yards.
Yards.
Square.
No, just yards.
That's what I said.
Okay. Okay, we'll stop right there. We got the